In this example problem, dealing with case E, we have two fair dice being thrown. A is the event that the sum of the scores is larger than 4, and B is the event that the scores from the two different dice are identical. And we're asked to calculate the probability of A intersect B, A union B, and complement of A union B. So we need to first come up with some way to depict these, and this is an example where there's often a unique way for a problem to be depicted that makes sense in your brain. And the one that makes sense for me is to consider the two dice separately, and I'm going to look at the first, oops, going to look at the case of each dice being thrown separately. So we're going to look at dice number 1, and you could get a 1, a 2, a 3, a 4, a 5, or a 6 with that dice. And for dice 2, we could get a 1, a 2, a 3, a 4, a 5, or a 6. Now, when we look at these, the total of the scores is 2, 3, 4, 5, 6, 7. Here it's 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. And notice that really that 9 corresponds to a 3 from dice 1 and a 6 in dice 2. So that's where that comes from. I'll just finish this little chart. 5, 6, 7, 8, 9, 10. Again, these numbers are the sum of the two dice score. And $12 being that I scored a 6 on die 1 and a 6 on die 2. And that's where those numbers come from. Now let's draw A. A is the event that the sum of the scores is no larger than 4. So no larger than would include 4. So this, whoops. I'll start again. No larger than 4. So it's just this portion of the 6 times 6, 36 outcomes possible. 1, 2, 3, 4, 5, 6 outcomes actually have a sum no larger than 4. So that's event A. Now B is that the scores are identical. Now this would just be the diagonals. So it would be the 2, the 4, the 6, the 8, the 10, and the 12. And that event is case B. Do they intersect? You bet. These two numbers right here are inside both. So let's see if we can answer the question. What's the probability of being in the intersection? A intersect B. That means you've landed on 2 of the 36 outcomes. So my probability, I'm just going to need to erase this bit so I have some space. For A, to get that probability, I have 2 of the 36 outcomes in that intersection. So I would take 2 divided by 36, and I get 0.0555. I better put 0.556 for rounding. Now, what's the probability of A union B? So in B, I want to be inside A or in B. And if you'll recall, I had 6 components, 1, 2, 3, 4, 5, 6 entries in A plus 7, 8, 9, 10. So 10 of 36 are in A or B, or A union B. So I would take 10 divided by 36, and I get 0.278. Lastly, I'm asked for the complement of A union B. I either want to be outside A or in B. So if you'll recall, what's the complement of A? The complement of A is everything other than the 6 entries that are in the circle corresponding to A. So, in fact, there are a total of 30 entries that are outside of A. So, in addition to being outside of A, you might also be inside B. That's what it means outside A or inside B. So you take the 30 that are outside A and you add to it the 2 that are in A but also in B. So we have 32 out of 36 entries that are in complement of A union B. 32 divided by 36 is equal to 0.889. And that's our answer for case C.